Hello and welcome to R4. This is my fourth video on registers. In this one, we're going to go over a vending machine change. I have a couple of questions here that I'll go ahead and explain, but first, let's demonstrate the circuit. So, basically, we can kind of break it down into category. So this is a vending machine where you can insert nickels, dimes, and quarters in order to get a product that is set at a price that can be changed. You can also get your money back if you'd like. If you haven't paid the full price already, or if you haven't selected your product yet. And then it also will display how much money you've currently put in the machine. So we can go ahead and try to order something. So say that. So right now this is it says price is equal to 8, and for every bit value, it represents a nickel. So for example, say that the price is say 8, well, or 8 in hexadecimal. That's going to be 40 cents. Because 8 times 5 is 40. And every single, how do I put it? Yeah, every single value is equal to 5 cents. So, yeah. So this is 40 cents. So say that I put in a quarter, and right now we're in state 5. That means that there's 25 cents in the machine. Say that we wanted to try to select a product. Well, we can't do it yet because we haven't paid enough money. So, and the money's still registered in there. So say that we put in a dime. It's like, okay, well, can we get the product now? No, we can't because that's 35 cents. Say that we put in another dime. Okay, well, now we're at 45 cents. So we can click our product select button. Now we can, we've selected a product. And then we can go back. And the weird thing is that with this circuit, and this is just straight taken from the teacher's example, so you can get it to light up green when you click the product select button at the same time that the final coin that knocks it over the edge, when I say knocks it over the edge, I mean takes it from not enough money to enough money. As long as that's high, and then you also press product select at the same time, then you can get it to light up green. However, if you and I'll just show you now, so that we restart, we can do 2 quarters. Now we have enough money. So that I do this, well, it'll reset it, but it won't light up green for that second. So you have to click product select while this quarter is still high. I'm not really exactly sure why that is. I went back and forth trying to copy as perfectly as I could, and it still does that weird thing. So I'm not really sure exactly what's going on there, but it still works. It's just there's that weird caveat to it. So that's kind of what it is. This is where the current money is displayed. So say that I've put in a quarter. Well, it's represented by this state 101, and that's how much money we have. And you could put this you could make this unsigned decimal if you wanted to, however you would like to display the value that's currently in the machine. So we can start with our questions now. It says, when designing, why should you ask yourself, what tools are in my tool belt? How did that question help us in this design? Well, this is more of a common sense question, but if you know what you have, then you have the freedom to make decisions within that domain. So for example, on this device here, instead of using some complex device to know when, or like a flip-flop or something to know when, or maybe a decoder, to know when we're supposed to put in or how our state will end up being when we put in a dime or a quarter or whatever. The values 101 are plugged into here, or 001 or whatever else is. We can just use this OR gate. And what that means is that because we know what we have, we can simplify the circuit a lot. And this can be abstracted to in the reverse way. You know, we could also make we can make this entire thing out of AND gates and OR gates and stuff, but because we know that we have a register in our toolkit, well, we can choose a register. We don't have to make a register literally out of just fundamental gates. And so, you know, you got to use what you have to your benefit, you know. Next question is, the general finite state machine model has 5 components. Name these components and identify where they are found in the vending machine circuit. So first we have the next state logic, and that is this adder here, this OR gate, all these NOT gates, and kind of everything on this like left quadrant is determining like what our next state is, but it's mostly this adder here. Our state memory is this register, and then our output logic is this AND gate with this comparator and this AND gate, or this OR gate, AND gate, and this comparator alongside like you know, the things that are being plugged into them. And then I suppose this mux as well. Yeah. So that is that. Oh, and then the input logic and the output logic. Yeah, so I guess these are not part of the next state. This is just the input logic. And then the output logic is this green, is this little light up thing here. Green if you can select a product, and not if you can't. Next question is this a Mealy or Moore machine? Explain. Well, it's a Mealy or Moore machine. Explain. It's a Mealy machine because it outputs high by using this product select button. So when this product select button is high, then the output is high. Like, it has to be high, right? And this is something that the user presses. So this is a Mealy machine. Next question is, what is the maximum money total that the register can accept? Explained using binary. That's 75 cents because our states are 4 bits. And so 111, 1111 rather, represents the maximum state, and if every like, you could say unsigned decimal value is equivalent to 5 cents, then 1111 represents 75 cents. Okay, so it says put 65 cents into the machine and don't select a product, then put in a quarter. What happens to the value in the register? Why? Explain the binary values you observe. So we can do that. Everything's cleared. We can just let's put in 65 cents, so that's 2 quarters, and then a dime, and then we put in another quarter. And what this is doing is basically it will give you back your change minus 5 cents. So for example, if I put in 75 cents, so 1, 2, 3, that's 75 cents, and then I put in another quarter, it says that I have 20 cents. So it kind of eats one of the nickels. Yeah, that's what happens. As to why it sheds off the 5 cents, that's a little weird. But I believe that's one of the downsides to this this circuit. It says Susie's using the vending machine. The price is 60 cents. She puts in 2 quarters and a nickel. She still needs more money to put in, so she puts in a quarter. But now she's upset because the machine ate her money. To avoid a situation like this, what is the highest safe price for this machine? Assume that Susie is reasonable and won't keep putting in money if she knows that she's paid enough. So we can reset. So the cost is 60 cents. So that means that this is 40. So that's 50, and that's 60. Okay, so basically we need to come up with the maximum amount of money such that she can't put in. Assume that Susie's reasonable and won't keep putting in money if she knows she's paid enough. So, let's see. So we need to come up with. So everything's in 5-cent increments. So say that we say 50 cents is the most that she can put in. And I think it's 55, but I'll explain why. So if it's 50 cents, then that means that if she has 45 cents in, then she'll put in, the most she can put in is a quarter, which would make it 70 cents. But if she has, and so that's safe, right? It just can't go over 75. But if she puts in 55, or say that it's 55 cents, then let's see. Okay, yeah, so if it's 55 cents, that means that if she put in 50 cents, then it'll go up to 75. Yeah, so that's the maximum amount. Because if she's at 55 cents, then she won't need to put in any more money. We're assuming she's reasonable. So 50 cents is the most that she could possibly put in without having paid for it, while also safely being able to put in another of the maximum possible currency. So yeah, 55 cents is the highest safe price. If pennies were accepted in this machine, how would that change the design? Well, we would have to have a lot of states. And that would just make everything literally infinitely more complicated. So the states would increase. The bit value would increase. Basically everything would increase. Upon restart, the machine might have incorrect values stored in the register. What instructions should be given to the vending machine manager after plugging in the machine to ensure that the products are not purchased for less than 40 cents? If that error did occur, would all feature products be undersold? How many would be undersold? Well, you should tell the clerk to hit the coin return button. That way you just set the register to 0. But if he or she didn't press the coin return button, then basically, no, not all of the products would be undersold. Just one product would be undersold, because that just means that somebody would put in however amount of money that is needed remaining. So say that like 20 cents were registered onto the register and they wanted to buy something for 40, then they would only have to put in 20, but then the machine would reset back to 0. So it would only like the first one would, but that can add up over time. So only one. In your circuit, temporarily disconnect the delay devices from the register clock. And in its place, connect a clock. Test the circuit now. Let's see. In your temporarily from the register clock. And in its place, connect a clock. Test the circuit now. Okay, I can do that. So I can I guess I can just delete this, and then I can get a clock. And then I can plug it in, and then I can, I guess I can just take it myself. Can I? No, let's actually see here. Let's do auto tick, and then let's make it slow. It's not slow enough. Let's make it super slow. Okay. Interesting. So if I make it super fast, then I could get a lot of snacks. Depending on how fast it is. Because it's counting the coins multiple times. I just left that on. Yeah, I'm getting a snack like super frequently. Let's see. So yeah, like if because it'll take times for the coins to do in the machine, right? So this could even flash for like just like a very short amount of time, but even then, like if I'm just holding down the button, then boom, I just got 2 snacks from 1/4. That's a big problem. What is the purpose of the delay device? Well, it's to make it so that, delete that and fix the circuit. Let's see, it's to make it so that the addition can be done here before it's registered into the circuit. That's why it does. Well, that's why it's there. And the OR gate feeds into it. Well, so that it can, be positively triggered when I do anything to it. Put in a coin or press the button. Why do we call this vending machine a controller? What other components of a vending machine exist? Let's see. We assume the existence of one of these components already. Which types of engineer would work on each of those other components? It controls it because let's see here. I want to say it's because we're limiting the amount of stuff that can happen with it. We're let's see. We're basically telling it what to do when something happens. The user puts in a quarter, and then we dictate what happens with the circuit. Same thing with the product select or the coin return or anything like that. Let's see. And what other components of a vending machine exist? And it says, we assumed the existence of one of these components already. Interesting. I don't know. I'm pretty stumped with this question. What other components of a vending machine exist? I don't know. Presumably getting the change, or I'm stumped. This is a tough one. Definitely have to get feedback on it. But regardless, I answered most of them. So thank you for watching, and I will see you in the next one. If you happen to know the answer to that question, please let me know. I appreciate it. Bye-bye.